compost. So that was Compost Week, tinyurl.com, Compost Week 2020, if you're so inclined. I think, and I wish she had said this, that the punchline that Rose had was that there's too much stuff going into trash that could be composted. And I think that's one of the big changes. 10 years ago, I feel like everything went in the trash, and now I feel like everything goes into the compost bin. And it's a big change in the way we all operate. I certainly notice it because I'm the food preparer at home, and we used to just throw everything in the trash can, and now we put it all in the green bin to be hauled away, which is quite a change. And it becomes useful stuff. So literally anything that was alive, I guess, at this point. I mean, the thing is, right, so to be stretching it out, dinosaurs were alive too, right? So why isn't oil part of the composting? But I don't know, it's a term of limitations there or something. Okay, so the big announcement, obviously, the elephant in the room. We will have a take-home exam. How do people feel about that? Yeah, I think, okay, all right, it's a crowd pleaser, right? Well, take-home exam. We are still waiting to hear more about suggestions for distance learning for now. So the last bullet here is that physical class meetings will continue for now, but they will have recordings. I'm just, as you can tell, I'm thinking about this in real time. What we also could explore doing is running Zoom here, and those of you who decided you didn't want to come into a large lecture hall could then join and chat questions and watch it live. And so let me think about how to do that. So what I'm currently doing is recording this. And if we were to move everybody at distance, then we'd be using Zoom. But I think I could also use Zoom if Air Bears 2 actually is robust enough in this room, which it often isn't, and that's kind of the problem. Okay, so I'll think about that. Take-home exam, we're going to iron out the details and keep you updated. So it's next Tuesday, and the main plan there was to make sure that it doesn't disrupt your life, so that it's doable within the 80-minute period that you have for this class on Tuesday. So if you wanted to do it during the class time, anywhere you want, you can. You can even show up here. Nobody else is going to be using this room on Tuesday if you want to. So that's the number one principle I have, is not to disrupt your lives. And the second principle is to make it, if anything, more flexible. Any questions about the take-home midterm plan? I haven't told you what it is yet, but I'm working on it. Questions? So that's our priorities, to keep the disruptions minimal for you. So we're going to suspend iClicker participation. So we're going to have measured everything we did measure, suspend it for now. With future physical in-class meetings, we will have iClickers, but the participation grade will be optional. I hope that you will come if we do have them, and if you don't, I understand why. And so we will not measure iClicker participation starting now until further notice. And I think I've touched on everything. I will hold office hours as usual for now, and if anything changes, I'll let you know. Questions? It's kind of fun, right? I don't know. Yeah, question. So the question is, what is the format of the take-home midterm? And so it's still a little bit of a moving object here, but I think what we're going to do is keep a similar format. We've already written the midterm. It's not finalized as what you've seen in the 2019 midterm, but it's going to be a take-home. So it won't be different. It won't be like a computerized thing, or it won't be an RStudio lab. It'll be like the exam that you have from last year. Yeah. That's a really good question. The question is, what is the benefit of coming into class to take it versus taking it wherever you want? And the answer is none. But if you need a spot to take the exam, you're welcome to come here. I'm sorry if I was confusing there. There's no reason to be here next Tuesday. We will get the exam to you probably electronically. If that changes, I will let you know, but I think that makes the most sense. Yes. If you come in, you would be taking it on your computer probably, or printing it out ahead of time or something. So we'll get everything in place sometime Tuesday morning at the latest. But again, the objective was not to make your lives more hard. So if this is the time you have to take the exam on Tuesday, then you can take it then. That's my objective. Yeah. Okay. Okay, the question is, so take the midterm during a specified time period yes, and then you said, so like log in and answer the questions, then log out. No, we don't have anything quite that complex. It's going to be more like the turn-in part of a lab. So you will get the exam, and it'll probably be in the form of like a Microsoft Word document, which most people can use. You can print it out if you want and then scan it, right, like people do for labs. So it won't be any kind of fancy computerized thing. It's going to be a document that'll arrive in some fashion, either via B courses or maybe emailed, or I think it'll be by B courses. Subject to change, but it would take a long time at this point to start doing a big thing with a lot of course infrastructure that we don't have. So that's what I think we're going to do, is that we're going to have something that is, you know, a lot like the in-class exam, but we probably won't print it out for you. You're welcome to print it out if you want and draw on it and things like that. And you also, I think, will be able to do it on a word processor of your choice, whether it's Google Docs or Microsoft Word or something else. Question?
So just to clarify, it's basically going to be like an assignment that we're going to take and then just turn it in by the end of the day.
That's right. It'll be like an assignment that you take. You know, it'll be like working on a lab and writing out the answers, but no R code, and there'll be some kind of a deadline. But again, the objective is for flexibility, so that it doesn't interfere with people's schedules and lives. Yeah. Yeah. Well, there are two things. So the question is, will it become open note, or it will be an honor code thing where we're expected? So those are kind of two things, right? One is whether it's an open book, open note exam, and we're talking about that. It might be. We're not sure yet. And the second question is whether it'll be an honor code thing. And it absolutely will be an honor code thing. So that will be on the exam. You will be expected to write out the very brief honor code and sign it on your exam, maybe with an electronic signature. But you will be on your honor the whole time, regardless of what the rules are exactly, but to play by the rules. Yeah. Other questions? Okay. So at the risk of making things a little bit, a little bit harder. Good, I am doing ScreenFlow right now. I wanted to just show you this. If I do the, let me go ahead and start this and show you just step by step. I wanted to clarify this because I don't think I made it very clear. About growth rate arithmetic. If you have something that looks like this, I just wanted to clear this up. This arose last time. So this is the pay-as-you-go tax rate, and it's a function of the benefit replacement rate, that's B over Y. And it's then multiplied by the old age dependency ratio, NO over NW. And let's just call this beta and omega. So omega for old age and beta for the benefit rate. A lot of things in life and in econ courses are multiplicative. The solo model is also multiplicative. You've got output is equal to capital to the alpha times labor to the 1 minus alpha, for example. Okay, so suppose the old age dependency ratio rises by 10%, then this is true. So a new omega prime is equal to the old omega times e to the 0.10. So that's a 10% increase. And a question might be, well, suppose you wanted to keep taxes fixed at this level for lack of a better term, little black t. So the same level of t that you see in the math above, you would need to find a beta prime then that gives you the same little t for this same original omega that's been increased by 10%. So you want to look for an expression for b prime that, in terms of b, that fits this. And here's one that does. So if you find that, that beta prime is equal to a 10% reduction in beta, you would find this math, the green stuff, right? Beta times e to the minus 0.1 times omega times e to the 0.1. And that simplifies to just beta times omega, meaning you have the same tax rate t at the end. So in words, what benefit replacement rate beta would you have if you wanted to keep taxes the same, but the old age dependency ratio omega went up by 10%? And the answer is you would have to have a benefit replacement rate that was smaller by 10%. So I'll absolutely take questions. I don't want to belabor that. I just wanted to toss it out there, and then we can get on to more important things. Yes? Yeah. Is there a reason I use natural log notation instead of, sorry, say 1 plus 0.1? Right? And the answer is yes. There is a small difference. And the way we typically think about taking percentage changes or growth rates will get you roughly to this, but with a little bit of an error. And so we can talk about that in office hours. But this kind of stuff is the way to think about it for a quick take that works also on exam questions. And if you're working through it numerically, you've got to be careful about whether you believe, this world. It's like the astronauts and versus metric or English units. You got to use the right approach to growth rates. It's either this way or it's the 1 plus the growth rate over 100 or however you like to phrase it. Other questions? Yeah. The benefit replacement rate is, I've defined it as beta here, it's B over Y. So little b is the benefit per retiree, and little y is income per worker. So a number like 0.5 for that means that the benefit per retiree is about half of what a worker's earnings are. Last class we had a slide that Emeritus Professor Ronald Lee, who used to teach this before Professor Goldstein taught it, and he had worked out that in the US, the benefit replacement rate is something like 40%, I believe. It's not very high for public pensions. Okay? All right, so with that said, now let me pop back out, and hopefully all this screen cap will be working whenever I figure it all out. I'm sure there'll be problems I haven't foreseen. Let me open the floor. So this is the review session. In office hours, we went over a decent amount of, I'm sorry, so I do want to do this. I want to say a few things. Notes about the 2019 midterm. So we didn't write it, and you didn't take that class. So there are differences. Things that are really hard for you. The takeaways that you should have, format similar, FOMRAT, I don't know what a FOMRAT is, format similar, and the topic coverage similar. So Ryan likes to write questions that rely less on remembering who Mr. X was and what he said. That I think was, to me, one of the most challenging things is some of the questions on last year's midterm were asking you what Piketty said or what Boserup said. And I think it's important to know that, Boserup is, yeah, what should you know? Boserup is Ms. Technology, and Malthus is Mr. Death, I guess you could call him, I don't know, Mr. Pessimism, and Solo is Mr. Capital. I think you should probably know that. I think you need to know that. Okay, questions about this? That really emerged. There are a lot of things that are pretty hard on the midterm last year, and because it's a different class, but it gives you a sense of the kinds of things that might be asked about. Okay, questions? It could be about anything. It doesn't have to be about the midterm last midterm that we passed out. Let me also say too, so we will give you the answer key later if you want that and help studying. So I think that would help. Based on office hours, that would help the students who arrived in office hours who wanted to see the answers. Questions? Yeah. That's a great question. I'm not sure it ever happens quite like that, but I definitely get your drift. Did I get this question right? When do things not shift at all in the short run, but still do in the long run? Okay. it's a little bit of an art to answering this, but let's see. If there aren't shocks to things, then generally stuff won't change quickly in the short run. What do I mean by stuff, though? Maybe I should be more specific. Stocks of things. I mean, that's really what it comes down to. Then stocks won't quickly change in the short run. So stocks are labor, people, capital. Think of that's kind of it, really. I mean, in principle, it could be land if we had that in the solo model. It could be other things that are like stocks of knowledge. Maybe I should put that down there, like knowledge, which is usually uppercase A, like a productivity shifter, right? That usually doesn't change quickly. So what are shocks to things? Shocks, and I apologize for that. Shocks, stocks are one thing, and then shocks are things like wars, mass immigration, what else? Plagues, I guess. Plagues that kill people really quickly. All right, those are shocks. Generally, things won't change quickly in the short run. So, for example, a rise in the saving rate will eventually raise little k and little y, but in the short run, only the rates of change rise, technically. So I think this is true. I also think that another useful question is to wonder about when things change a lot in the short run but don't change in the long run, which is a different question, but it's related. You know? So stop me if you think I'm kind of not answering the thing you're really wondering about. Other things, so a rise, or I guess usually it's a Piketty thing, like a reduction in the population growth rate. So this is S, and the population growth rate is N. Will eventually also raise K and Y, but in the short run, only rates of change are rising. So we're stuck in the short run at the old steady state. Eventually, a reduction in the population growth, and it pivots the depreciation curve downward or clockwise, and so it gives you this higher steady state level of capital per worker, and you'll arrive there eventually in the long run. Yes, question, yeah? What about a change in technology? And could you say the second half of your question again? Yes. Change in the rate of progress, right? Yeah. Okay. So my answer is, first of all, this is hard. And the reason is consistent technological change is real, but we haven't really modeled it well for you in this class. Usually that happens when you get to graduate school. So this is a little hard. I'm trying to think of what to say about this. I think what we have said is that trying to get to this place, we've drawn, like there's another name for it after an ecologist, but like the shelves of technology and things like that. So if you have an increase in technology, it shifts out the labor demand curve. You could view it then in the Malthusian model as pushing you up to a higher level population. That happens again. You could think about that also in the Solo model, that each time you've got some shelf of technological change. So it would do two things. So each time technology improves, you get a jump. So let's talk about the Solo model. Each time technology improves, you get an upward shift in the output curve and saving per worker, SF. So the whole, it shifts both those things up, and so when the saving per worker curve rises, because in this case, there's better technology, so it's giving you more bang for your buck. So even with a constant saving rate, you get more capital. It'll give you a higher steady state, but eventually that would, peter out. You'd reach this higher steady state, so you'd have to make some assumption. Well, you'd have to have some story about what happens after that all. So you could think of it that way. And we all know that in reality, technology is always changing, right? With iPhones, that's probably the most obvious one, right? Uber and Lyft weren't around like 5 years ago. All right, so technology is always changing. The issue is, I guess, how to think about that differently. So those are different. I think I'll stop there and ask if there's a follow-up to help clarify, or if there's a different question. Yeah. Ah, okay, that's a really good question. Okay, so suppose there's a one-time improvement in technology. What happens in the long run? Back to the original steady state. Okay, and the answer is no, usually not. An increase in technology in the Solow model shows up as an increase in A. We're in here, let me try to insert an equation. All right, so what's happening here? You've got little y is equal to some productivity factor A times K to the alpha or 1/3 or whatever you like, that kind of thing. Oops, that didn't give me an exponent. There we go. Okay. So the curve permanently shifts up. And this will produce, other things equal, a permanently higher steady state K star. Does technology wear off? Usually not. Once you develop a new production technique, it's yours and you have it. And so it means that capital per worker is producing more output per worker at every level permanently. Would it help to graph this? Or do we want to ask a different question? Question there on the side? So you're wondering about the short run versus long run? Okay, so maybe let's just talk about it. I just happened to do this. All right, so we've got several of these, and let me try to make this clear. One of the problems is that once you start tossing in all these curves, and all of them kind of matter, so this is the output curve up here. Let's call it, so y is f of k, little f of little k is up here. And so what we're saying happens, let's label all these things. Here's our capital per worker, little k. Here's our output per worker and also saving per worker and things like that. So let's see if I can put it in a little line here. Whoops, I guess I did it the wrong way. And let's change it to red, I guess, I don't know. So this is what we're talking about. I'm sorry, so you know what, let me just write what I did in the previous slide. Did it again. Come on, PowerPoint, you could do this. If I can do it, you can do it. This PowerPoint is definitely younger than I am, that's for sure. All right, so here's our new output curve up here. Let's call it y prime, I guess, and it's going to be up here at a prime. And now I'll put in a text box that explains when technology increases a to a prime. And so the story here would be something about better, say, tree harvesting technologies, or better bows and arrows that hunts deer, or agricultural techniques that manage to pull more out of the land. I guess now in the solo model we're talking about better production techniques given capital and labor. So it would what? It would be new ways of combining factories and people into, say, I don't know, delivering products to people's doorsteps instead of having them all come to the factory or something like that. Okay, so this kind of thing happens, and then also underneath it all, let me try to make these different colors. Is that still, yep, still fairly legible there. So here is the saving curve that's down here. And let's copy this over. And let's see if I can make this text green just for kicks. Okay. So technology does both of these things, right? It increases these, it increases the total output, and with the same rate of saving, this is also going to happen. This thing shifts upward here. So you guys have probably seen what the ending to the story is going to be. Let me just put in the last piece of this, which is going to be the depreciation curve. And it's going to be looking something like this. If the story is about technology changing, we don't have anything happening with the depreciation curve. Let me change the color to, what have we used? Red. I guess red's sort of the best one, isn't it? I guess maybe purple could be. Well, we can't see the difference there. Well, whatever. I shouldn't have bothered. Here's the depreciation curve, and that's a little bit more boring. It's just n plus d times k, and that is what it is, and it doesn't do anything fun. Okay, so finally, so we'll have a k star and a k star prime down here. Here's our k star. I guess I should have done this. You can do it. Come on, PowerPoint. You can do it. You can do it. Oh, I see. I have to do a space. That's what I got to do. Oh, did that wrong. How many economists does it take to make PowerPoint work well? More than one. Okay. K star prime. And here, I guess, would it help to have a little drop arrow or something? All right, so K star prime is up here at this intersection. And here's K star. I guess it probably would help, right? I'm not hearing any screams from the audience, so I'll go ahead and keep doing this. Okay. Yeah, I guess the neat thing about this is that there are several different points that are interesting. So if you have, all right, so here's y star. So if technology changes overnight because of a scientific breakthrough, what's interesting is that K star will stay at the same level in the short run, but output actually rises immediately because you can deploy the technology quickly. You don't have to wait around to build the capital to use it. So it would be a story about capital or things like, trucks and buildings. Those all are still existing. People are people. And then there's a new development that makes the people using the trucks more efficient. And that happens overnight, so they all learn about it and they're able to, let's call this y prime, I guess, and then there's going to be a new y star prime way up here. So they're able to increase output right away. Let's see if I can put a star up in there. So there are two different steady state levels of capital per worker here. You start off at K star, you'll end up at K star prime at the end of the day. And there actually are three different levels of output that are salient. One is the first level, Y star, where you're at before the technology change, and then technology changes and magically all your labor and capital is more productive, and so they produce more output all told, and also output per worker rises. And then over a longer period of time, you'll end up here at Y star prime. I'll post these slides too, in addition to the video. Other questions? Yeah, question in the front.
Can you go through the Malthus model that's on the midterm? The questions 2, 3, and 4?
Yeah, we can go through the Malthus model that's on the midterm. Are there other questions about solo before we leave? Yeah.
So, just the short run, the midterm mixture is
Oh, that's a really good question. So her question is, so in the short run, the only curve that jumps is the output curve up here at the top and not the saving curve? And the answer is that they both jump in the short run, but what does the saving curve tell you? So we're at this point in terms of saving per worker after this technological change. So that's true, and there is more saving per worker. But it takes a while for that to actually affect this variable, capital per worker. So both curves shift up, but the economy doesn't jump around in terms of the capital stock. It stays right there in the short run. And then over time, because the saving, I was about to say something incorrect, because total saving per worker has risen because productivity is higher, so output per worker is higher, and if you're saving a constant rate, then so is saving per worker. That is also higher. That means that over time, this gap between depreciation per worker and saving per worker will produce new net capital per worker and push us toward this new steady state. There's a lot of nuance here, isn't there? Yeah, question.
In the practice test, there was like two shapes happening at the same time in one of the problems. We just do like two separate graphs showing each shape, or do we just do them at once?
The question was, when things are confusing and multiple curves are shifting, how do we show that? Do we draw two graphs or what? And I think what happened in the practice midterm was that there was a change in the population growth rate and also a change in the saving rate. Does that sound correct? Yeah, I think so. And, so when, quick answer, do your best. Longer answer is, we'll try to make that clear that, if multiple things are happening, maybe you need two graphs to show it. Maybe you can show it all on one graph. And we will give some thought to how you are humanly expected to draw something like this on a take-home exam, which is a little harder, right? So we can all do this on a paper and pencil, right? That's easy, and you try to do it in a way that makes it clear. Doing what I have been doing is not that easy, as you probably have noticed, because of how long it's been taking me to do it. And I'm not sure we expect you to do that sort of thing. So we'll come up with a plan for that. More generally, though, right? These models can get complicated quickly. And my advice to you is to try to maybe make a list of all the things that you think are happening during a particular scenario. Here we've covered it all, and in the practice midterm it was different. There were more things happening. And you have to illustrate them all and tell the full story. Other questions about solo before we do Malthus? Okay. So I think we're doing the video recording. I haven't actually written down your questions, but they'll be on the video at least. Question in the back?
Just one question.
Yeah.
When you go up, when the savings shift up,
Yeah.
in the short run, is the capital, the savings goes up to the second, like shift, right there, right?
Yeah.
And then it will
That's right. So maybe if I drew some shapes. So her question is, when this technology change happens, maybe that's a little too large, I don't know. Saving rises up to this funny little blue circle that I've now drawn, and let me do a different color there. So maybe I'll make this one green to make clear that that's where we are at in terms of saving. And here, oh, this is the old one, but I'll call it, I'll show it as purple because that's where depreciation is. So in the short run, the economy, if you will, is still at K star, but the values of these curves are at the green point and the purple point after this shift has occurred. Yeah, that's right. And so these are different, and the distance between them is the amount of new saving per worker net of depreciation. It's the extra saving per worker that then actually pushes the economy in this direction up to here, up to this new steady state. And so just for kicks, I guess I should make this one maybe red or something. This is the new steady state over here. Solo model is not easy because it's a story about stocks that change slowly over time. So reading it correctly is it's something one needs practice doing, I would say. Other questions? One last thing. One of the good news parts of the good news is that the same kind of phase dynamics, the time part of all this, is the same really with Malthus and Solo. So that's some consolation, right? It operates in the same way that you can be on a curve at different places, say where the birth and death rates are different, and that will then push you back toward a particular spot, and that's the same with Solo. Question?
Can you explain about
That's a tough one, and I think what you're getting at is the midterm of the very hard questions about Piketty and the marginal product of capital. Do you remember where those were in the? I think it's here. So page, what is this? Page 7. So why don't we? I'm going to give you a short answer quickly, and then we'll come back to it after we do Malthus. The short answer here is that number 4 is especially hard. And it is not something I would expect you to be able to do. And we didn't, so last spring's class was different, and we didn't spend much time talking about this. So that's the short answer, is that this is hard. This is PhD level stuff. The slightly longer answer is we can talk a little bit more about this. I think number 3 is more fair game given what we covered in class, but again, it's still very hard. So we'll come back to it after we talk about Malthus, okay? Okay. Any last questions about Solo before we leave that? Okay. All right, so question about Malthus in the front row. I'm sorry, I'm totally spacing your name again, but even though you've been upstairs a bunch, but yes.
I want to go over like
2, 3, and 4, which must be on, I suppose, this, right? Is this it? The community leader implements a child limitation policy. Is that what we're talking about? Okay. Do you have a specific question, or you wanted to just kind of go over it? Is that okay? Okay, all right. The community leader implements a child limitation policy in the Malthus model. Each household can have only 2 children and must petition the leader if they want to have a third. Before the child limitation policy, the average number of children per household was 4. Choose the statement which describes the correct short-term change on wage and population levels. And so I think we are catching a break that there is one correct answer here, not multiple correct answers, and also no 0 correct answers, I think. Okay, our job is to translate this question's phrasing into what happens in the Malthus model with the curves. And so I wonder if I can import one of these things. Kind of hate to just draw the whole darn thing all over again. Okay, so let's, can you take a stab at what you think? If you have that question text in front of you while I try to pull up something to help me do this. Maybe I should just start and just eschew that altogether, because that's really where we started, right? It's trying to translate what the question text is into something that makes sense to us. So by all means, though, if you'd like.
And so I thought it was either C or D, which is like the gradual increase in wages. But I just
Okay.
wonder in the short term, can you see if that has gradual increase in population? Because I'm assuming he's gonna like implement this policy, but how drastically will the population change?
Okay.
But not everyone's having like.
Oh yeah, okay, you're getting, oh, that's very clever. So if we look back at the text, yeah, not everyone is having kids that would make this a binding policy, right? That's what's kind of tripping you up. Yeah, that's hard, right? Yeah. I think that the way through this maze here, so what she's getting at is this part about the policy. Each household can only have 2 children, must petition the leader if they want to have a third. And what you're thinking is, well, okay, but not everybody has or wants to have 3 or more children. Maybe some people only want to have 0 or 1 or 2. So what has happened here? We've run into the disagreement between reality and the toy models that we do on exams especially, but generally when we're modeling things here. So that's absolutely right. And I think the hint here was, before the child limitation policy, the average number of children per household was 4. And I think the strong hint is to pretend that everybody's the same and they all have 4 children. I think that's the way through this forest. So if I were to think about it, though, I would have to, because I think you have a very salient point here, is that, suppose though in reality this was not the case, that people were having different numbers of children, and it seems to me the policy would have a different effect on average if there was variation that included people who were having fewer than 3 children, who were having 2, 1, or 0. It's a different economy. And I'm pretty sure the answer key does not reflect that reality. So try to keep these answers as simple as you can. And I'm pretty sure the question was not trying to get you to think about that the effect would effectively be dampened. The impact would be dampened if the reality of what you're talking about was actually happening. And then in a second, let's actually do this question and talk about the answer. Yeah?
My question was more that like in the short term, I'm not sure if we would see like a sudden like decrease.
Okay.
Like, so I kind of understand like it's not asking about reality, it's just like giving the information so we know that people are having more than 3 children. But I don't know that in the short term, like is the population gonna like decrease like.
Well, and that gets us, so what she's saying is there a quick, large response in the short term or what, right? Is that what you're saying? And then you found suddenly we're back in solo, right? The same issues. It's just different things that are going into it all. So, okay, let me take a screenshot and put this into PowerPoint. I hope this is going to work and not explode my machine. But so this is the one we're talking about, and let's take it and copy it and put it over into PowerPoint. Okay. Okay. So the idea here is that the birth curve falls, right? There's fewer births across the board. It's a story about the birth rate. I guess that's another problem that one might run into, is that if you think about the birth curve, what are the units on it? Are they number of children? And that might make you think rather, stratospherically, that perhaps the birth curve changes shape somehow, like maybe it rises up from 0 to 2 and then flattens or something like that. And I think we need to try to keep this as simple as possible. That this policy is a story about a reduction in births, a binding one. So if the average births per household was 4, and now the ruler says, well, it's 2, and maybe you could get a third if you do this petition. It's a story about a reduction in the birth curve. Do you guys agree? It's always a little challenging, right? It's a different class, different exam writers, and I think that's what we need to do here, is try to keep this, fairly straightforward. Okay, so if that happens, so then what? And now we're getting into the interpretations of the short term and the long run in the Malthusian model, and a careful step through of those sorts of things. Okay, and so now let's shift to the Malthus model and see what happens. And maybe in the interest of time, we can go back and do the curves. I'm just reluctant to kind of dive in there because it does take a long time to actually, sort of plot all these things out. So what happens if the birth curve falls? Okay, so I always have to think about it. In the upper diagram, so the death curve is the one that's downward sloping through the wage, right? You get fewer deaths, the higher the wage is. So that's the death curve. And then the birth curve is the one that is concave down, I guess. Well, not really. It's always rising, right? It's monotonically rising, but at a diminishing rate. So if the birth curve falls, then you're going to have this X here. And so you're going to get a new long-term steady state that's that way, toward Florida, right? Towards the southeast. So the population is lower, and that kind of makes sense. You've got less fertility, fewer births, right? And you've also going to have a higher wage. Okay, so that's in the long run. So if the birth curve shifts down, then the new long run steady state, long run, will occur to the southeast. Higher wage and lower population N. Okay. All right, do we agree? Hope I'm getting it right. When you're doing it in your head, there's always a really good chance that you're screwing it up, and I'm not drawing it, but I think this is correct. Okay, so which one of these do we think is correct? A, sudden drop in both wages and population level. Well, I think, come to think of it, so this is a shift in the birth curve. That's the story. It's not a crazy biblical thing where like children are being slaughtered or some awful thing, right? It's not that. It's a story about a change in the birth rate, right? So people haven't been born yet, and they'll be born at a slower rate. So this is a slow change in population and other sorts of things. So I think right off the bat we can rule out A and B, which both seem to say sudden. Now, that said, I guess if you're talking about wages, if what we were modeling involved some shift in the labor demand curve, there could be a sudden change in wages, but maybe still not a sudden change in population. So I think A and B are both incorrect. Choose the same which best describes the short-run change in wage and population levels. So gradual increase in wages and a sudden decrease in population level versus gradual increase in wages and a gradual decrease in population level. What do folks think? C or D? D is better, I think. That's right. So I think the answer is D.
We make the same assumptions with like you said about the shocks, like wars and stuff like that.
Well, okay, so what you mentioned in his question is, can we make the same assumptions about shocks like wars and things like that? And I think those are just fundamentally different, right? A shock like a war is pretty different than this kind of scenario.
No, I mean like the same assumptions you said earlier about the solar.
And now you're saying that the same assumptions that we made earlier about the solo model.
Yeah, where you said like where it wasn't gradual, it was a shock. When it was like examples like.
Oh, I'm sorry. Right. So okay. I understand now. So you're talking about this slide, right? If there aren't shocks to things, then generally stocks won't change quickly in the short run. That's right. It's the same story. The Malthus and Solo are thankfully very similar in this regard. Yeah. And this is not a story about a shock. It's not a crazy, right? That would be, I mean, it wouldn't, I don't know. It's only funny when you're actually taking the exam or writing it to have some ridiculous biblical story of like, the Pharaoh going and like, killing people or something awful like that, right? It's not a story about that. It's a story about the change in the birth rates. It's not a shock. It's a change in the rates that are being applied to the population. Other questions? Yeah. Yep, we can talk about that. Any more questions about Malthus? And then we'll come back to this, if you like, the marginal product capital and Piketty stuff briefly. Other questions about Malthus? Okay, and stages of the demographic transition, right? Okay, so before we do that, let's do, a little bit more. I mean, would you like to hear more, or, okay, you would, yeah. it's, I'm gonna, yeah, I'll try to keep it brief without not saying anything. So, would you like to hear about number 3 or number 4 or both of them? Both, okay. Oops. Screw that up, okay. Okay, so let's just put them here. So, sorry for, it's small type for the folks in the back. It is on page 7. Okay. So, let's see, what do I want to do? Yeah, that'll be good. Where's my solid fill? Well, I guess I can, maybe if I start writing. No, that's not going to work either. Just trying to get space to actually write something. Okay, so number 3, Piketty argues that slower population growth contributes to increasing inequality. Which of the following is part of his explanation of this connection? Choose all that apply. Okay, there's a longer song and dance about how to try to answer these, which is that you want to look for factual correctness, factual accuracy of the statement, and then whether or not the statement actually was attributable to that person. Those are 2 different things, and that'll sometimes trip you up. Okay, capital income is more unequally distributed than labor income. So let me first ask, is that clear to people what that means? That was an issue in office hours, that some folks weren't sure what it means to have capital versus labor income. Labor income is paid to labor, capital income is paid to capital. And if you think about it, most of us in the room probably have labor income or have in the past, and probably very few of us have capital income. And so this is a factually true statement. That capital income is less equally distributed, and it also is attributable to Piketty. So A is one of the correct answers. The savings rate increases when growth is slower. So I'm not sure how to suggest going about this, but I guess I think one is to assess whether that's factually true. And how would you do that? I think you would take the Solow model and think about that. In the Solow model, the saving rate is a parameter. There's nothing in particular that ought to tie it to the population growth rate, which is, I think, what growth is supposed to mean here, and it did in Piketty and Size's paper. So I think that B is not correct, factually correct, and I also don't think it's something that Piketty said was true, I think. And I would have to check. Yeah. I think what he talks about is population growth changing the capital output ratio. That's different from the saving rate. The saving rate is a parameter that doesn't shift unless we say it does, that kind of thing. So I don't think B is true. C, slower growth makes capital per worker increase, and so I just said that a sentence ago, that is true in the Solow model. Capital per worker increases when you have slower population growth. And so it's the story about the Solow curve. Let's just look at it, I guess, since I drew it, right? It's rather than the saving rate changing, it's a story about this thing. So if the population growth rate N becomes smaller, then the slope of this whole thing becomes smaller, and this whole thing pivots clockwise, or if you like, shifts down, and it will give you a higher level of capital per worker. So that is also true. Slower growth makes capital per worker increase. I'm sorry, I didn't do the second half of this, right? You can see how challenging these are when it's like, what did Mr. X or Ms. Y say? It is also the case that Piketty and Size actually say this, that the slower growth in population makes capital per worker increase, and we saw it in the slides. So to review, for C, the solo model tells you this, and also Piketty says it too. So it's also one of the correct answers there. And then finally, and 3D is closely related to 4, and this is the PhD level economic stuff, that the capital share of income increases as capital deepens. That's a very complicated sentence, and it refers to the share of income that is paid to capital as opposed to labor. And he does say this, so this was a correct answer on the midterm. He does say this, and this is true that this would contribute to inequality, basically given A. So A is true, so capital income is more unequally distributed, and so if the capital share increases as capital deepens, then you're sort of doubly in for it, right? Things are even worse. Yes? What? Yeah, capital deepening, good question. Deepening means K star rises. So more capital per worker. So I'm pretty sure we are not asking you on this year's midterm to talk about the rising capital share of income. That's like PhD level stuff. But if you do have a question about it, go ahead and ask, and I will answer it. We have about 20 minutes left, so we might spend our time on other things. Yes? Sudden change in immigration, bringing technology or not. Okay, great. And I realize too that we've actually skipped over this one, so we'll do this one first. The stages of the demographic transition, right? And the specific question about the demographic transition, was there? Okay. Sorry, did you have a specific question about the demographic transition? Okay. Stage of the demographic transition. So the key things to know, yes? We're going to post the answers, yeah. Key learning objectives. So mortality falls first. Then fertility falls. I guess I should just narrate this all out. Then population growth rises, then fertility falls. Along the way, because of this sort of bulge, if you like, of surviving babies who grow into workers, when they do, that is a demographic dividend, meaning more productive more productive capacity of the economy, if you like. It's also true, of course, that they need capital to be productive, but even if it were the same capital stock, there still would be an increase in output because you've increased the amount of labor because of this bulge of surviving babies. So that's what the demographic dividend is. Are there other questions about the demographic transition? Yeah. Are there names for different stages other than early and middle and late? And,
I think maybe 2003 has some names that I don't think they're canonical.
Yeah. We won't ask you to remember them because we don't know what they are, if there are any. Okay. Do you remember which class it was, the immigration iClicker question? Yeah. Okay. That's okay. We'll recreate it. Okay. How to think about that? So it probably was a solo model thing. It could have been either one. Probably solo model. Okay. So this is important. It's important whether and two things really. Immigration is a one-time shock, that's one thing, or immigration is a change in the population growth rate. So those will get you into different places. And I think the story probably was a one-time shock of immigrants, and then it got complicated because it's also important whether immigrants bring stuff, and they could, in theory, bring capital. I mean, it's, this is figurative. They show up with cash and they buy capital, I guess, but I think that's the mechanism that one is imagining here. So yeah, and that's all I'll say about that because we're short on time. And they could also bring technology, and that's I think a little bit more obvious. That technology is shorthand for knowledge, and you might have it written down in a book or of course these days on a computer. But it's something that you can easily transport, and so somebody could hop off a boat or a plane and have information that they share, and that changes technology very quickly. And so I'm guessing, I can't remember for sure, but I think the tricky thing was if immigrants arrive with no capital, if a shock of immigrants with no capital, but with technology, with new technology, then you'll see a leftward jump because so if you have a big increase in L, then you get a so let's see, right? So change in L means like a negative change in little k. It's because little k is equal to big K over L. Okay, so having said that, there's another part here that's tricky. So let's look at the Solow model. So this is little k along the horizontal axis, and so if you have a bunch of immigrants, or you could call them whatever you want, people who just show up and they start working, there will have to be a leftward jump in the economy because capital per worker falls suddenly. There are more workers around, so capital per worker becomes a smaller number overnight. Questions about that? That's kind of obvious, right? The tricky thing, so that's a leftward jump, and then also an upward shift in little y and little s times little y because of changing technology. So I'm going to do a bunch of hand waving here, but let's look at the graph again. It's I guess we could quickly diagram this in a copy. It is this kind of story where, so this will still happen and this will all still happen, it turns out, because technology has changed, but we're also going to have, in fact, it's very similar to this, isn't it? We're going to have this short run, depending on how big the immigration shock is, this short run, let's call it K, I don't know, 0 or something like that. So immigrants arrive and they push the economy down to this interesting point here. Okay, so they reduce capital per worker immediately because people show up immediately and they start working immediately. And then we get this very interesting, convoluted, complicated story. I think I need to take out a y prime in here though. So I think I need to change this into a, what am I calling it, y0, I guess. That's sort of counterintuitive, but I'll stick with it. So this isn't relevant anymore. This guy needs to be shorter. Okay, so when immigrants arrive with technology, with tech only, right? So they don't arrive with capital. So, okay, this is really tough, isn't it? Here's our short run position. Okay, I think I got this right. So we're still going to end up here in the long run. Immigrants arrive, it's a one-time shock, so they do not change the population growth rate. They don't change the saving rate, but they bring new technology with them. So that's why a lot of the curves are still doing the same thing that they did back in this example with technology increasing. But the addition is that immigrants arrive without capital and they start working. So that means that in the short run, they will reduce capital per worker from K star down to K0. And I think I've drawn it correctly here. So the purple line, that's depreciation, that stays the same. The green line, the saving curve, shifts up immediately though when technology improves because output per worker shifts up immediately because technology improves. In the short run, we'd find ourselves down here with a big gap between saving and depreciation per worker. So a very large amount of investment per worker that will start to push us rightward. So we've jumped from K star down to K0. We're climbing back up toward this red point up here. Output also falls in the way I've drawn it. Oh, and the other thing about that iClicker question was, is there ambiguity? And there is technically, because of these two different sort of effects on output here. It turns out that output falls in the short run because this immigration shock was so large. But suppose I had drawn this first shock that pushes capital per worker so far down. Suppose I had put it over here. Suppose I said, well, actually, the same amount of technology was brought by a smaller number of immigrants who pushed us down to some level of capital that was right in here. Let's see if I can do some different language of this. Suppose it was KH for K happy, right? This is super happy, right? Because at that point, what we would see is a higher level of output per worker in the short run because of the technology shock, even though the arrival of immigrants has actually reduced capital per worker. And that was the very, I think, counterintuitive and confusing ambiguity of all of this. It depends how big these effects are. So YH, suppose a smaller number of immigrants brought the same amount of new technology, it would have been better for everybody immediately. Y star would have risen to YH. K star would still have fallen to KH, but the point is that you can be in this sweet spot here with this kind of like a triangular sort of view if that had happened in this sort of, in this way. In the real world, what would we say? Well, suppose the immigrants who arrived were just such smart people. And of course, the fact is that a lot of immigrants are extraordinarily smart. I can't wait to get to talking about this in this part of the class because there's a lot to be said about the competition that very low-skill immigrants present to domestic native-born workers with low skills. But it's also true at the level of me, and many smarter people than me also compete with very smart immigrants all the time. Immigrants are really smart, and suppose you had this policy where the immigrants that arrived were extraordinarily smart with a lot of new ideas, and they brought this bumper crop of technology with them for only a very small number of people. So they do reduce capital per worker in the short run, but it might be that the number of ideas they bring are so valuable they actually push up output per worker in the short run. Questions? So let me just add to this then. The short run effect on output depends on the bang for the buck, the bang for the buck, the bang for your buck. How many immigrants actually are bringing that much technology? So we've got 6 minutes left. Yes? When you're moving from the green dot to the red dot, is that attributable to the technology, or is it movement to the steady state? I guess I think both are true. It's mechanically, it's because there is this difference that has opened up. Let me kind of clean up things a little bit and take out these guys just to make things clearer. Okay, so KH is gone. Okay, I think that's the right picture. The story begins with immigrants and technology, and it produces this kind of story. And so the difference between the green and the red and the purple, rather, is this new excess investment or saving per worker, and that will raise capital per worker up to this higher level K star prime. It's because immigrants arrived and they brought technology. Yeah, I mean, it's because of technology. This movement to the right is because of technology. Other questions? Okay, well, we'll stick around for a little bit. Wash your hands. Try not to do what I just did, which is touch your face. I'm awful at that. Stay in touch. We will update you.